Hello YouTube, this is Jessica Stamy PKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. As you remember, in the last tutorial, we introduced the filters, the basic filters, grayscale, sepia, brightness, contrast, and all those guys. And we did that in the last tutorial. I'll show you how to use grayscale, how to apply brightness, sepia, to the whole image. In this tutorial, what we're going to do is we're going to open an image, but I was able to add different filters. We have all the filters from the last tutorial, as you can see, but we also have these other more advanced filters. We have here convolution, edge detection, noise, vignette, posterize, pixelate, and motion blur. And what I did was that I took some of the let's open this other image here because it's got more contrast. And what I did was that I was able to use the functionality from the cropping tool. If you remember the cropping tool, you open an image and then let's say dollar, and you use the cropping. For example, you crop, then you crop an area, and then you did all that. We did that in a few tutorials ago. And what I'm doing now is I'm using that same functionality, the cropping tool, but I'm applying it to the filters, to the advanced filters. And what I'm going to do, using the same type of functionality, for example, let's say that I want to apply convolution to this one of these images, and then let's say I want to do it to this convolution to just that one, Gaussian blur. So I just choose the area that I want to apply the Gaussian blur. Then I say yes, and it only applies blur to that area. How cool is that? And I can do it for other ones as well. Let me just toggle back so I don't want to save the other stuff. Let's say that I want to add edge detection. I can do Sobel or Canny. So let's say that I do, actually let's just leave it at 5. And now let's say that I want to apply edge detection to this filter right here, to this protein. It's asking me apply to the selected area, say yes, and there you go. Or you can also do the advanced filter. Let's say, let's do motion blur. And let's see, that's good. 45 seconds is fine. And then let's say that you want to do it to the whole image. You can also have the ability to the whole image. And did I do it? Let me toggle, make sure that I'm clean. Now let's try again. Advanced blur. Let's do, maybe it was not enough. Let's do 220. Then apply. And now let's try again to the whole image. And then say yes. And there you go. It has that motion blur that almost gets you dizzy from looking at it. So let me get it out of there before you. So this is the type of filters that you can do, and you can do all. You do pixelate also, like for example, let's do 15. Apply. Let's do this one now here. And just this is how you blur people's faces. You can use it for all kinds of applications. And there you go. And that's what we're going to be, I'm going to be showing you how to apply these filters. And the beauty of it, you can do it to the whole image or just one section. Um, for example, I'm going to do it to the whole image, Pixelate. Yes, there you go. And so let's get started and see how we can do this. So let me minimize this for now. And the way we're going to do that, I wanted to show you um, a couple because these are more advanced algorithms. The last tutorial was more basic stuff, grayscale, hue, color, all that. This is a little bit more advanced, and I'm gonna show you two good books that I read in the past. This one is Python based. I read it many years ago when it first came out. I thought it was a very good book, introductory book. That's a good one to start with if you just and now you can find them at a very inexpensive price because uh, it's a little bit older now. This one I think is the best book on computer vision, and it's free. You can actually go to his website and you I downloaded the 2022 edition. You just go to his website and you can, for example, where is it? Let me go back here. I'll just show you. You can go to the website, his website, and you just down download, put your email address, and you can get a free copy. He's made it available. I remember when this book first came out in 2010, I believe. Great book. This was it's a little bit of a more of a steep learning curve. It's a little bit more difficult than this one. That's why I say this is more of an introductory book. This one gets more involved, and but a lot of the stuff that I'm going to be using, you can, if you want to read more into what's going on with these separable filters and Gaussian filters, all of the math is right here and how they work under the hood. And so because I don't have we don't have the time to do that in 20-minute tutorials. This is you can spend a whole month, a whole a whole year on this book. So I'm just going to touch at the very top because I'm gonna be using some of the algorithms that he's using, but we're just scratching the surface. This is not you can go there and then really go deeper if you're really interested. But this is what, because the reason I'm saying this, because when you go to OpenCV, the OpenCV library, the documentation page, you're going to see I'm gonna be using something similar to this equation. And if you, for example, this is this equation, and sometimes you're gonna see people using this equation, sometimes you're gonna see people using this equation, and you say, what's the difference? They're related, they're not the same, but they're very close, very related. This one is more done more when you're doing stuff that is anisotropic, meaning that you need to know, you're gonna have, you want to know what X and Y directions are, and you're gonna have different ones. For example, for medical imaging, for satellite imagery, you that type of information is very important. For the type of stuff that we're doing, we need fast computation and not too computationally intensive stuff because we're doing real fast stuff, making it faster. using large kernel, so you don't want to be using uh, most of the time you don't want to be using this. You can, and for that reason in the code, what I did was that I added here the equation also, so it's there. But I just wanted to let you know that I'm using the other one. I'm using the more simple, and what the difference is that in this equation, you're using you're assuming that sigma, you're only using one instead of using two, one for sigma for x and sigma for y. And also, what else is different? The means, I'm assuming that they're the two, the radius. For example, here, I'm centering the radius here into two. So that's just to make it simpler to use. I just wanted to let you know, just in case you see that other equation and you say, "Oh, but that equation is not this equation." There are two different ones, and you're gonna be seeing them used for Gaussian filters for different applications. We're going to be using that one because in the edge detection filters and some of the other filters, the pre-processing always tends to use, not always, but most of the time tend to use Gaussian filters before you apply Sobel on it, or before you apply Canny on it, or motion blur, or whatever. And like in the other tutorial, this is going to be once I show you one, the other ones are going to be very similar. In this, for example, the convolution, you've seen all of these because, for example, if I do the convolution tool, the programming logic of the convolution tool is the same programming logic that we use for the cropping tool. So you're going to be seeing, if you remember, we were doing events when we click, drag, and release the mouse. We did that in the tutorial with the cropping tool. So it's the same logic, same programming logic that we did. So we're not reinventing the wheel. We're using stuff that we have used, that you've seen before, and we're applying it to these other functionalities. I just wanted to give you an example. So let me go back. And all of these filters, like convolution, they are very, very similar. I mean, for example, sharpen will use intensity, and convolution might not use it, or motion blur might not use it. But those are very, very minor differences. So if you, from the last tutorial, you're already familiar with most 70% of this code, and you'll see it. For example, we're including, all the stuff that we've been doing in all of our tutorials. We're bringing image crate, we're bringing image filter, crop selection, just like I just mentioned from the cropping tool, which is, if you remember, is right there. It's this guy right there. So we're going, what else? This is the enum for the convolution type of the filter that you're using. The radius is going to determine the kernel. Sigma is the standard deviation. Intensity, that will be used for the sharpen filter only. The other two will be using kernel. And that's why the intensity here is optional. It's an option T, because not everything will have it, right? So sigma, same thing. Uh, what else? Here we're creating this. There's the box blur, and if you want to know the difference between the box blur and the Gaussian blur, you can go to here, OpenCV. They talk about the box blur. the difference and the kernel that they're using, the matrix. Um, and it's good because you can go here also to the OpenCV library if you don't want to get into the nitty-gritty stuff from the math of the book that I show you. You can come here also because they explain how to use Sobel, what's going on under the hood for the Sobel and also for Canny. So you can see here, and this is what I was talking about, the pre-processing. You're applying Gaussian filter first to filter out the noise. And that's why I'm talking about the Gaussian first, because you're going to more likely apply it whether you're doing Canny or Sobel or any of the other filters. So this is the intensity, that's for sharpen, this Gaussian blur, just like I said, the kernel, standard deviation, intensity, this is not for this case. Gaussian blur, selection none. This is sharpen. This is using intensity, that's why it's using the clamp. Um, and you've seen all of this stuff. This is the math part that we talked about, where you applying the equations to create the function for the Gaussian kernel, and then create the box kernel, create the Chapman kernel, apply the kernel, and then just do RGBA like we've been doing row by row in every tutorial. And you see the pattern. You keep seeing the same pattern. You keep seeing the same. Basically, they differ here and there, but the programming logic, the basics are very similar. That's for the convolution. For the let me motion blur. I'll just you see it almost looks the same like the other. This one is using angle though because of the algorithm is it works with angles instead of the radius. It has a feather radius for the smoothing, and it's got the kernel size. What else? The application, the selection is going to be the same. That's for the selection. This is for the this tool. Cannot think of the name. Much blur tool. And then the distance, the inside selection, create the cosine and sine because we're using angles. So that's the radians, angle to radians. It's doing the calculation, creating the line, normalizing the kernel, so it looks good. So it's normalizing to 1, so it equals 1. And here is the implementation block. And this is where the magic, where the pixels by pixels, the row by row, and the RGBA. So you see the pattern. And this is the only one that is a little bit more, is different from the others, but still very similar. For example, if I show you, let's do Pixelate. Well, let me show you the filter, not the tool. So if we do Pixelate, very, very similar to the Gaussian filter, as you can see. But if you want to learn more about what's going under the hood, I really recommend that you go to either one of those books or at least go into the OpenCV library documentation, and you're going to see, how they get the gradients, what do they mean by a 3 by 3 kernel, one in the X, one in the Y, and the math that is gets into it. It's very interesting. I mean, it's all linear algebra. That's all it is. But and you can go there and learn more about it. But this is what we are going to do, and then, like I said, there are 7 filters there that you can use, and they're very easy to use. So you can have a choice to use Sobel or Canny. So for example, so you can see it, let's do another one, 0.3, and now apply it. Let me download this to get the original. I like to do it a couple times just to make sure it's not there anymore. So then do filters, advanced, and then let's do edge detection, Canny. Let's do a 0.7, apply, and then just choose the whole area. If you want to do the whole image, apply yes, and there you go. And you can use Canny, you can use Sobel, you can decrease it, increase it, whatever your application requires, and you have the flexibility to do one area, to do the whole image, to do a section. You can do all kinds of stuff, especially I was using this already for an application. I was applying noise, and it's nice to have the flexibility to just apply noise to one area. For example, let's say that you're testing some, let me toggle again, toggle. Let's say that you want to apply noise just to one section. Let's apply it, let's go with 8, apply. Let's say that you only want to apply noise to this section. For any particular reason that you're doing an application that you just want to test that for whatever reason, you can see there the noise, and you can increase it, decrease it, all you want, and you only apply noise to that section. But play around with it. I think you like it. I'll have the code ready in my GitHub by the end. I think by the end of the time that you watch this tutorial, it should be there. But this is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time with another tutorial. Take care.